Hello students, there are many students who have confusion related to series and parallel combination of bulbs. The main confusion is when all the bulb will glow equal and when unequal. So let's clear this confusion step by step and by using proper example. So let's see first the series combination. And in series combination there are two cases. In case 1 we will take three identical bulbs. So first bulb B1 is of 5 ohm and bulb 2 is also of 5 ohm and bulb 3 is also of 5 ohm, and all three bulbs are connected in series with the EMF, or we can say voltage, of 15 volt. Okay, so as we know that by Ohm's law V is equal to IR. So the first point, the total resistance of all three bulbs is nothing but 5 plus 5 plus 5. So the total resistance, that is RS, is nothing but 15 ohm, and it is connected to the 15 volt battery. So we can say I is equal to V upon R, which is equal to 15 volt upon 15 ohm, which is equal to 1 ampere current. So from this circuit 1 ampere current will flow throughout the circuit, and at the end it will come back to the negative terminal 1 ampere current. Okay, so now let's see which bulb will glow brighter. So the brightness of the bulb does not depend only on the current, but it also depends on the voltage as well as the resistance. So in 8th standard there was one formula for the power. So power is equal to V into I. And in 10th standard you will get the same formula, that power is equal to V into I. And in 10th standard there is another formula, that is power is equal to I square into R. R is nothing but resistance. Okay. So we will see for the bulb B1. So for bulb B1, resistance is equal to 5 ohm and current is equal to 1 ampere. So power for the bulb 1 is equal to 1 square into 5, which is equal to 5 watt. Similarly for the bulb 2, P2 is equal to I square into R 5, which is also equal to 5 volt. And similarly for bulb 3, P3 is equal to I square into 5, again it will come 5 volt. So here we can see the power of all three bulb is same, that is 5 watt, 5 watt and 5 watt. So the power is directly proportional to the brightness. So in this case we can see that brightness of all the bulbs are same, hence all bulb will glow with same brightness. But there are many students, they ask that first bulb will glow brighter, second will glow less, and third will glow least bright. So to solve this confusion, we will take case number 2. Now in case number 2, we will take three unidentical bulbs. Okay. So first one is B1 of 2 ohm, B2 of 3 ohm, and B3 of 5 ohm. And all these three bulbs are connected to the 10 volt of battery. So again the first step, the total resistance is equal to 2 plus 3 plus 5. 2 plus 3 plus 5, which is equal to 10 ohm. And voltage is given 10 volt. Therefore by Ohm's law I is equal to V upon R, which is equal to 10 upon 10, that is 1 ampere. So again in this circuit also current flow is nothing but 1 ampere. Okay. Now here we have to again see that which bulb will glow brightest. So the second point, we will consider the first bulb, that is B1. So in B1, resistance is equal to 2 ohm and current is equal to 1 ampere. Just now we saw that power is nothing but I square R. So I is nothing but 1 into R, that is 2. So we will get 2 watt. For bulb 2, resistance is equal to 3 ohm and current is equal to 1 ampere. So power of second bulb will be I square R, which is equal to 1 square into 3. So we will get 3 watt. And finally for bulb 3, R is equal to 5 ohm and I is equal to 1 ampere. So power of bulb 3 is again I square R. So we'll write here 1 into 5. So 1 into 5, that is 5 watt. So here we can see the power of third bulb is greater than second and which is also greater than 1. So we know that power is directly proportional to brightness. So the brightness of third bulb is greater than brightness of second bulb. Brightness of second bulb is greater than first one. Okay, so in this case we can say that more is the resistance, so more is the brightness, or we can say current is the same. So here resistance will decide which bulb will glow more brighter. Clear? Okay, now let's go to the parallel circuit. Again, in this parallel combination we have two cases. In case 1 we will take three identical bulbs. First bulb B1 is equal to 5 ohm, B2 is equal to 5 ohm and B3 is equal to 5 ohm, and the voltage connected is equal to 15 volt. So here we can say first point, current from the bulb 1, current is equal to V upon R1. Okay, so V is nothing but 15 upon 5. So we will get 3 ampere current. Similarly for I2 is equal to V upon R2. Again we will get 3 ampere current, and again I3 is also 3 ampere. So total current is equal to I1 plus I2 plus I3, which is equal to 9 ampere. So 9 ampere current will start flowing from the positive end. Here will pass 3 ampere, then 3 ampere, and then again 3 ampere, and at the end again we will get 9 ampere current back to the negative terminal. Okay, so here we can see that the same amount of current is passing through all three bulbs. Okay, so now let's see about the brightness, second point. Now for the parallel circuit, we know that power is equal to V into I. Okay, and V is equal to IR. So can I write I is equal to V upon R? So I will substitute this value here. This formula is not in 9th standard. It will come in 10th standard. Okay. So V square upon R. For the parallel combination, we will use this formula for power. Power is equal to V square upon R, because in this case voltage is same and in series combination current is same. So for bulb B1, resistance is equal to 5 ohm and voltage supply is equal to 15 volt. So we can say that therefore power for the first bulb is equal to 15 square 225 upon 5. So 225 upon 5 is nothing but 45 watt. Okay. Similarly, can we say for the bulb B2, resistance is equal to 5 ohm and V is equal to 15 volt. Therefore, we will get P2 is equal to 45 watt. Again for B3, that is bulb 3, we will get P3 is equal to 45 watt. Similarly, just same like bulb 1 and bulb 2. So here we can say parallel combination P1 is equal to P2 is equal to P3. Therefore, we can say all bulb will glow with same brightness. Now let's see the same parallel combination with three unidentical bulbs. Now let's see the same parallel combination with three unidentical bulbs. So here we will take B1 is equal to 2 ohm, B2 is equal to 3 ohm, and B3 is equal to 5 ohm. And voltage is connected to the 10 volt. Okay. So first we will find current passing through each bulb. So for bulb B1, I1 is equal to V upon R1. So V is equal to 10 upon 2, which is equal to 5 ampere current. So from here 5 ampere current will flow. Second, I2 is equal to 10 upon 3, which is approximately equal to 3.33 ampere. 3.33 ampere. And I3 is equal to 10 upon 5. So we can say 2 ampere current will flow. Okay. So from here bulb 3 2 ampere, and here 3.33 ampere current will flow. Now let's see about power. Similarly, we know that power is equal to V square upon R in parallel combination. So for bulb B1, resistance is equal to 2 ohm and voltage is equal to 10 volt. So power 1 is equal to V square upon R. V is equal to 10 square upon R is 2. So 100 upon 2 is equal to 50 watt. Similarly for bulb B2, P2 is equal to 100 upon 3, which is equal to 33.3 watt. For bulb 3, power 3 is equal to 10 square upon 5, which is equal to 20 watt. So here we can see power of bulb 1 is greater than 2 and it is greater than 3. So we can conclude that brightness of bulb 1 is greater than brightness of bulb 2, and the least brightness is of bulb 3. Okay. Here we can conclude that in parallel circuit, the bulb with lowest resistance will glow brightest as compared to the resistance of higher resistance, as compared to bulb of highest resistance. So at the end we can say the first part, that is series, and the second part is parallel. Identical glow equally, and unidentical brightness is directly proportional to resistance. Okay. And in parallel, identical glows equally, and and unidentical Brightness is inversely proportional to resistance. Thank you.